In the history of British firepower, some weapons were proudly designed, built and adopted at home. Others had to fight their way in against politics, pride and tradition. This is the story of a light machine gun the British Army did not want. A foreign design from Czechoslovakia, rejected on principle, resisted by industry, attacked in Parliament, and yet, once war came, it became the most trusted weapon in the section. This is the story of the Bren gun, the British machine gun, that should not exist, but ended up defining Commonwealth firepower for nearly half a century. The year is 1933. The British Army faces a crisis of modernization. Across the nation's armories, the Lewis gun that served through the Great War has reached the end of its effective service life. Heavy, cumbersome, and increasingly unreliable, the Lewis represents outdated thinking about infantry firepower. Military planners understand that modern warfare demands a new breed of light machine gun, one that can be carried and operated by a two-man team, fired from a bipod in the prone position, and deliver sustained, accurate fire at ranges exceeding 600 yards. The doctrine is clear. Each infantry section requires a portable automatic weapon that combines the mobility of a rifle with the firepower of a machine gun. Yet producing such a weapon proves extraordinarily difficult. Throughout the late 1920s and early 1930s, British designers submit prototype after prototype. The Vickers-Berthier shows promise, but suffers from feeding problems. The Beardmore Farquhar demonstrates innovative features, but lacks reliability. Domestic designs from the Royal Small Arms Factory at Enfield fail to meet exacting military standards. Each failure deepens the crisis. Britain's infantry doctrine depends entirely on section-level automatic fire, yet the nation that once led the world in firearms innovation cannot produce a suitable weapon. The solution emerges from an unexpected source. In Czechoslovakia, the Zbrojovka Brno armaments factory has developed a remarkable light machine gun. The ZBVZ-26, designed by Václav and Emanuel Holek, represents a quantum leap in automatic weapons technology. During extensive international trials, this Czech weapon outperforms every competitor. It functions flawlessly in mud, sand, and Arctic conditions. Its rate of fire remains controllable. Its accuracy exceeds that of many rifles. British observers witness demonstrations where the ZB continues firing long after British, French, and German designs have jammed or overheated. The test results create an impossible situation. Britain needs this weapon desperately. Yet accepting a foreign design represents an unbearable blow to national pride and industrial prestige. The British Empire, spanning a quarter of the globe, admitting it cannot manufacture its own infantry weapons. The political implications prove nearly as troubling as the tactical crisis. Members of Parliament question why British factories and British engineers cannot solve this problem. Military traditionalists argue that dependence on foreign designs threatens national security. Trade unions protest that adopting Czech weapons will cost British jobs. Industrial magnates suggest that given more time and resources, domestic alternatives could succeed. These objections carry weight beyond mere prejudice. International tensions are rising across Europe. Relying on weapons manufactured in another nation creates strategic vulnerability. If political circumstances change, if alliances shift, Britain could find itself unable to arm its forces. The War Office faces a dilemma with no comfortable solution. Reject the Czech weapon and leave the infantry inadequately armed. Accept it and acknowledge British industrial failure while creating potential supply dependencies. Necessity ultimately overcomes pride. In 1935, Britain purchases the manufacturing rights to the ZB design. However, the acquisition comes with conditions that reflect lingering resistance. British engineers insist the weapon must be substantially modified before entering service. The original design will be transformed, adapted and improved until it becomes, in official rhetoric if not reality, a British weapon. The manufacturing license transfers to the Royal Small Arms Factory at Enfield Lock. Here, British engineers begin their work of transformation. The modifications are extensive and purposeful. The original ZB fires the Czech 7.92mm cartridge. Britain requires compatibility with the .303 British cartridge that has served since 1893. This necessitates redesigning the chamber, bolt, and gas system. The magazine, originally mounted at a moderate angle, is repositioned to a more pronounced 30-degree upward cant to facilitate reliable feeding of the rimmed British cartridge. The bipod undergoes strengthening to support sustained fire from prone positions. The sights are recalibrated for British ranging standards and tactical requirements. The barrel quick-change mechanism receives refinements to improve speed and reliability under combat stress. Each modification serves practical purposes, but collectively they achieve something more significant. They allow Britain to claim the weapon as its own creation. The designation itself reflects this transformation. Bren, an acronym combining Barno, acknowledging the Czech origin, with Enfield, asserting British ownership. In official documentation and public pronouncements, the weapon becomes described as designed at Enfield based on Czech principles rather than as a Czech weapon manufactured under license. Production begins in 1937 at Enfield. The manufacturing process demands precision far exceeding that of bolt-action rifles. Each component must be machined to exacting tolerances. The barrel requires specialized steel and precise bore dimensions. The gas system needs careful regulation to function across varying ammunition types and environmental conditions. Initial production runs proceed slowly as workers master these demanding techniques. By 1938, production accelerates, yet Britain enters the Second World War with far fewer Brens than military planners consider adequate. The technical sophistication of the Bren represents its greatest strength and initial challenge. The weapon operates through a gas-actuated system that harnesses propellant gases to cycle the action. As a round fires, gas travels through a port in the barrel into a cylinder containing a piston. This gas pressure drives the piston rearward, unlocking and opening the bolt. The bolt extracts and ejects the spent cartridge case, then strips a fresh round from the magazine during its return stroke. A powerful spring drives the bolt forward, chambering the new round and locking the action before the firing pin strikes the primer. What distinguishes the Bren from competing designs is the refinement of this mechanism. An adjustable gas regulator allows the operator to increase or decrease gas flow, compensating for carbon buildup or environmental factors. The system proves remarkably tolerant of dirt, debris, and moisture. While German machine guns of the era require meticulous maintenance and American designs demand clean ammunition, the Bren continues functioning under conditions that would render lesser weapons inoperable. The barrel change system demonstrates similar thoughtful engineering. Sustained automatic fire generates tremendous heat. After firing 200 rounds, a barrel reaches temperatures that affect accuracy and risk structural damage. The Bren addresses this through a quick change mechanism requiring mere seconds. The operator releases a barrel lock, lifts the carrying handle, and withdraws the entire barrel assembly. A replacement slides into position, locks with a single motion, and the weapon resumes firing. This capability allows sustained fire far beyond what fixed barrel designs can achieve. Properly managed, a Bren crew can maintain nearly continuous fire by alternating barrels. The top-mounted magazine initially appears a peculiar choice. Most light machine guns employ bottom-feeding magazines or belts. However, the top-mounted design offers significant advantages. The pronounced upward curve, necessary for rimmed .303 cartridges, positions naturally when mounted above the receiver. The magazine remains clear of dirt and debris when firing from prone positions. The operator can observe rounds remaining by simply glancing at the translucent magazine. Loading proves faster and more intuitive than with bottom-mounted systems. The curved magazine holds 30 rounds, though experienced crews load only 28 or 29 to reduce spring tension and prevent feeding failures. This capacity provides sustained fire while maintaining reasonable weight. Unlike belt-fed machine guns requiring dedicated ammunition bearers, a single soldier can carry the Bren and sufficient magazines for extended engagements. The weapon achieves the perfect balance between firepower and portability. Weight considerations drove every design decision. The complete weapon weighs 23 pounds, substantially lighter than contemporary medium machine guns, yet heavier than rifles. This weight provides stability during automatic fire while remaining manageable for rapid repositioning. The bipod folds beneath the barrel when the weapon is carried and deploys instantly when needed. Mounted on its bipod with the butt firmly against the shoulder, the Bren delivers accuracy approaching that of precision rifles despite firing fully automatically. Rate of fire reflects another carefully considered compromise. The Bren fires approximately 500 rounds per minute, significantly slower than German or Soviet machine guns, capable of 800 or more rounds per minute. This deliberate design choice enhances controllability and accuracy. Faster-firing weapons climb off target during sustained bursts and consume ammunition at unsustainable rates. The Bren's measured pace allows aimed fire at individual targets. British infantry doctrine emphasizes precision over volume. The Bren exemplifies this philosophy perfectly. When British forces deploy to France in 1939, the Bren accompanies them in insufficient numbers. The expeditionary force possesses fewer than 3,000 guns, far below the establishment of one per infantry section. Priority allocation goes to frontline units, leaving reserve and support formations with aging Lewis guns. This shortage proves fortunate in one respect. When German forces shatter Allied lines in May 1940 and British troops evacuate from Dunkirk, relatively few Brens are abandoned on French beaches. The weapons that return to Britain become precious assets for rebuilding shattered divisions. Dunkirk transforms British perception of the Bren from interesting new acquisition to essential survival tool. The weapon's performance during the fighting withdrawal demonstrates capabilities that reports and peacetime exercises merely suggested. Bren gunners hold defensive positions against overwhelming numbers, their accurate fire disrupting German attacks and covering retreating comrades. The weapon functions without failure, despite appalling conditions. Caked in sand, soaked in seawater, dropped and abused during desperate retreats. Soldiers who board evacuation vessels clutch their Brens, knowing these weapons represent their best chance of survival when they return to fight. The experience galvanizes British industry. Production accelerates dramatically. Additional factories convert to Bren manufacturing. The Monotype Corporation, normally producing typesetting equipment, retools completely for weapons production. Small workshops manufacture components under subcontract. By 1941, monthly production exceeds 5,000 weapons. The Commonwealth joins this effort. Canada establishes production at the John Inglis Company in Toronto, later moving to Long Branch Arsenal. Australian factories at Lithgow begin manufacturing a modified variant suited to Pacific conditions. India's Ishapur arsenal produces thousands more. By war's end, total production exceeds 30,000 weapons monthly across this global manufacturing network. The North African campaign provides the Bren's proving ground. Desert warfare tests weapons mercilessly. Sand infiltrates every mechanism. Temperature extremes stress materials beyond design limits. Water for cleaning is scarce. Maintenance must occur under combat conditions. German machine guns, magnificently engineered for European conditions, falter in African sand. The MG-34, beautiful in its precision, jams when sand enters its complex action. The MG-42, faster and more powerful, proves equally vulnerable to environmental contamination. The Bren thrives where others fail. Its loose tolerances, considered a manufacturing flaw by some engineers, become a battlefield advantage. Sand passes through the action without jamming. The gas regulator compensates for fouling. The simple, robust construction survives abuse that destroys more delicate weapons. British infantry sections learn to trust their Brens absolutely. Before attacks, Bren gunners receive priority for ammunition resupply. During withdrawals, sections ensure their Bren escapes, even if other equipment must be abandoned. The weapon becomes more than equipment. It becomes the foundation of tactical planning and the guarantee of survival. Tactical employment evolves through combat experience. British doctrine positions the Bren as the section's primary weapon. The rifle group exists to support and protect the Bren, not the reverse. This represents a fundamental shift from Great War thinking, where machine guns supported riflemen. In section attacks, the Bren provides covering fire while riflemen maneuver. In defense, the Bren holds the critical position while rifles cover approaches. This tactical organization spreads throughout Commonwealth forces, defining infantry combat methods for decades. The weapon's accuracy enables employment beyond traditional machine gun roles. In skilled hands, the Bren engages individual targets at ranges exceeding 600 yards. Single shots, fired with careful aim, strike point targets that would challenge rifle fire. British soldiers discover their Bren can eliminate enemy snipers, silence opposing machine guns, and engage observation posts with precision that astonishes German troops accustomed to area suppression fire from their own weapons. This versatility makes the Bren simultaneously a precision instrument and an area weapon, adapting to tactical requirements that would require multiple specialized weapons in other armies. Manufacturing evolution continues throughout the war. The Mark I, produced from 1937, represents the original design with all refinements from Enfield engineering. The Mark II, introduced in 1941, simplifies certain components for faster production without compromising functionality. The Mark III, appearing in 1944, eliminates the drum rear sight in favor of a simpler aperture, reflecting combat experience, showing that most engagements occur at ranges below 400 yards. The Mark IV never reaches production before war's end, but incorporates further simplifications for peacetime manufacturing. European battlefields from Normandy to Germany demonstrate the Bren's sustained effectiveness. In hedgerow fighting, where combat occurs at close range amid restricted visibility, the Bren's controllability and accuracy prove decisive. In forest battles, where engagement distances shrink further, the weapon's reliability under stress separates victory from defeat. During river crossings, where weapons suffer immersion and mud contamination, the Bren continues functioning when other automatic weapons fail. Through the bitter winter fighting of 1944 and 45, through rain and snow and freezing conditions, the Bren serves without complaint. The Pacific Theater presents different challenges. Jungle humidity rusts steel and rots wood. Tropical diseases weaken crews. Japanese infiltration tactics demand constant vigilance. Here too, the Bren proves itself. Australian troops in New Guinea rely on Lithgow-manufactured variants, modified slightly for tropical service. British forces in Burma carry Enfield and Indian-made weapons through monsoons and across mountains. The Bren's sealed action resists moisture better than open-bolt designs. Its weight, sometimes criticized, provides stability in the chaotic close-range firefights characteristic of jungle warfare. By May 1945, Commonwealth forces field over 350,000 Bren guns. This represents one of the largest machine gun production programs in military history. Every British and Commonwealth infantry section possesses its Bren. Support units, headquarters companies, and even rear echelon formations carry the weapon. This saturation of firepower transforms Commonwealth tactical capabilities, providing volume of fire previously associated only with much larger forces. Post-war, while other nations rush to adopt newer designs, Britain retains the Bren. The weapon that entered service amid controversy now enjoys universal respect. Soldiers who carried it through 6 years of war trust it absolutely. Commanders who planned operations around its capabilities see no reason to change. When Britain adopts the 7.62mm NATO cartridge in the 1950s, the Bren transitions seamlessly. Rechambered and redesignated as the L4 light machine gun, it continues serving without interruption. This conversion demonstrates the design's fundamental soundness. Changing calibers typically requires extensive redesign. The Bren adapts with minimal modification. New barrels, modified magazines, adjusted gas settings, and the weapon functions as reliably in the new caliber as the old. The L4 serves through the Malayan emergency, the Suez Crisis, operations in Kenya, Cyprus, Borneo, and Northern Ireland. Each conflict confirms the Bren's enduring value. Commonwealth nations follow similar paths. Canada maintains its Brens into the 1980s. Australia employs Lithgow variants well beyond that. India continues manufacturing and using the design into the 21st century, producing millions of weapons at Ishapur for domestic use and export. New Zealand, South Africa, and numerous other former Commonwealth nations retain Brens as their primary section automatic weapon decades after other nations adopt more modern designs. This extraordinary longevity stems from characteristics apparent from the weapon's first trials: reliability under adverse conditions, accuracy sufficient for precision engagement, controllability enabling sustained fire, simplicity permitting field maintenance, robustness ensuring long service life. These qualities, evident when British observers first witnessed the Czech prototype, remain relevant across changing tactical environments and technological evolution. The Bren's influence extends beyond its direct military service. Its design principles inform subsequent light machine gun development worldwide. The quick-change barrel becomes standard on modern weapons. The balance between portability and sustained fire capability defines the light machine gun category. The emphasis on reliability over theoretical performance guides military procurement decisions. Nations developing indigenous weapons study the Bren, learning lessons from its success and applying them to new designs. For the soldiers who carried it, the Bren represents something deeper than mechanical excellence. It embodies trustworthiness under the worst circumstances humans create. When everything else fails, when communications break down, when support vanishes, when the situation deteriorates beyond planning or hope, the Bren continues functioning. This reliability creates bonds between soldiers and weapons that transcend rational analysis. Veterans speak of their Brens with affection and respect, remembering particular weapons and specific moments when that reliability preserved lives. The weapon Britain initially resisted became Britain's most successful infantry weapon of the 20th century. The Czech design British pride rejected became the symbol of British firepower. The foreign gun British industry modified to claim as its own became genuinely British through adoption, adaptation, and decades of faithful service. The political controversy surrounding its acquisition faded as combat performance silenced critics and vindicated proponents. Looking back across 8 decades, the Bren story is more than a technical success. It is a reminder that armies do not always recognize the right answer when they first see it. British officials resisted a foreign machine gun for reasons of pride, industry, and politics. In the end, the battlefield made the final decision. The Bren served from the late 1930s into the 21st century. It fought in Europe, Africa, Asia, and the Pacific. It armed regulars, reservists, colonial troops, peacekeepers, and insurgents. It survived new calibers, new doctrines, and new generations of rifles and machine guns. And it kept its reputation for reliability until the very end. Today, most Bren guns are silent. They sit in museums, collections, and regimental messes. Yet for the soldiers who carried them, the memory is simple. This was the gun that always worked. A Czech design, rebuilt at Lee-Enfield, trusted across the Commonwealth. The machine gun they did not want at first, and the machine gun they later refused to give up. If you enjoyed this look into military history, make sure to subscribe for more stories about legendary and forgotten weapons. Tell us in the comments what firearm you would like to see next. Your suggestion might inspire our next episode.